Kendra, and I am by no means a professional computer programmer. I'm a pregnant housewife in Saskatchewan, standing in front of a green screen in my basement. 20 days ago, I had never heard of Delphi or Rad Studio, but in those 20 days, I've managed to create a fully playable computer game. In this video, I'll showcase how my game appears to the end user, and then take you behind the curtain to show you how it looks in the programming environment. Then I'll give you my top 5 hard-earned tips for building your own application. My game is a digital version of a card game in which the user plays against AI opponents. In that way, it's similar to Microsoft Hearts. I'd argue, though, that my game is objectively more fun than Hearts, in which the cards are in straight rows and it's all very sterile. I wanted my game to simulate the full experience of playing cards with neighbors on a Saturday night. The AI opponents have faces and voices and personalities, so let's hop right in and see.
When you click on the desktop shortcut to launch my game, you're brought to a home screen that presents 2 choices. You can get a quick refresher on the rules of what is a fairly complicated card game, or you can start playing. A box where the user can enter information is called an edit box.
I'm Alice.
What's up? I'm Bob.
The name's Clarence.
And I'm Diana. Putting voices, sound effects, and music in your Delphi program is super easy. These buttons, where the user can pick one of 4 options, are called radio buttons. Playing my game, the user has to press a green arrow in the corner a lot. I've skipped to a part where each of the 4 AIs are laying a card in turn, so you can notice that in between each card, the user presses the arrow. In Microsoft Hearts, that doesn't happen. Instead, the AI cards appear automatically, separated by a momentary pause. That's probably possible with Delphi's sleep function, but I haven't figured that out yet. So for me, creating the illusion of a next button was essential. More on that in tip 5. Skipping to the end of the game, notice that the user can check the score at any time simply by hovering over the picture of the score paper. Alice has 120 points. That means she's going to win. As you can see, an awesome game, especially for a first effort. Now let's open it in the programming environment and see how it works. You'll recall that my game consisted of 3 different windows: the home screen, the rules window, and the main window where all the fun happened. Each of these are separate units. Opening the project railroadauction.dproj automatically opens only the home screen unit. To open the exciting one, we go over here and click newgame_u.pass. The first thing you'll want to notice are the 2 tabs at the bottom that say Code and Design. When you're programming, you're going to toggle between these tabs a million times, so you can work in the code and work in a representation of the graphic user interface as it will appear to the end user. The code for my game is 14,000 lines long, so let's begin with a tour of design mode. All of the things that exist as part of my game, like for example that picture of the score paper, are listed in the top left. Delphi offers many different types of things, but to make my game, I only used 6 types. Because scorecard icon is what's highlighted, that's the thing we can learn about in the bottom left part of the screen, the Object Inspector. Object Inspector has 2 tabs, Properties and Events. In Properties, we change how things look. In Events, we change what they do. To make my game, I didn't need to bother with the vast majority of properties in the Properties tab. I don't know what you do, I don't know what you do, or you, or you. For images, I only ever needed to touch Multi-Res Bitmap, Position, Rotation Angle, and Visible. Multi-Res Bitmap is what you click to change the picture itself. The image called Scorecard Icon is currently a picture of a scorecard, which makes sense, but we could change it to a picture of the goer name tag if we wanted. It's important to understand that all of the images that can appear throughout my game are here right now. You just can't see them. In the fun of the game, if Alice's score goes over 100, she wears a Santa hat. We can find it in the top left listed as Alice Hat. Since you want to see it, I'll set it to visible. But it's normally invisible at the start of the game, and stays that way until we reach a line of code alicehat.visible:= true. That's Delphi's for take the object called Alice Hat, go to its property called visible and change its setting from false to true. Here's the big trophy from the end of the game. Now you see it, now you don't. Back to our score paper icon, let's check out the Events tab. As with the Properties tab, I didn't need to deal with most of the stuff in my first 20 days. The only events I used were onClick, for all the things the user could click on, and onMostEnter and onMostLeave, for the things the user could hover over. You'll recall that hovering over the scorecard icon caused the score to appear. Clicking onMostEnter in the Events tab brings us to the part of the code that made that possible. A list of instructions to change all the various parts of the score paper display from invisible to visible. And now, on to the top 5 tips for Delphi beginners.
1.
To stay organized, before you ever open the programming environment, create a new folder on your desktop exclusively for the new project. I used to be a kindergarten teacher, so what I have in mind for my second Delphi application is a sequential collection of 100 phonics minigames. I'll come up with a better name later, but for now, let's call it Phonics 100. When you open Delphi and start a new multi-device application, you'll see it opens a blank form in a blank unit. The default name is Unit 1. Rename it. I'm making a load screen for my phonics game, so I'll call it Load Screen. Now go to Save Project As. Do not save your unit in the suggested folder. Choose the folder you created on the desktop. Something crazy is about to happen. It's going to prompt you to save 2 files right in a row. The first is your unit, which you've already renamed. The second is your project as a whole, which may come to encompass many units. So I'm naming mine Phonics 100. Now press the green play button to run your project. Now, when you go to your folder on the desktop, you'll see it's filling up. Let's count the files. 1, 2, 3, 4, 5, 6, and a folder in the folder, another folder in the folder, 2 more files. And you'll never need to bother with most of them. Now, tip number 1 is this. In the folder called Debug, create 2 new folders called Images and Sounds. If you keep all of the content your program will use in these folders, calling them from your program will be a cinch. Time to gather some content for my Phonics 100 load screen. Maybe I want a polar motif. I'll choose a stock photo of Antarctica to use for my background. I'll make an icy logo on cooltext.com, and I'll find a wintry sound effect on freesound.org. I'll save them all to the Images and Sounds subfolders I just created. Now, when I return to my Delphi project, that content is at my fingertips. To insert images, type Image in the bottom right corner and select T-Image. Then, as aforementioned, use the multi-res bitmap property to change it from blank to the picture you want. I want to make my icy sound effect start as soon as the load screen opens. If you want to have any sound at all in your program, you need to go to that insert area in the bottom right and insert a media player. Now, the event that I want to trigger the sound is the load screen form opening. So in the top left, I select Form so that the form as a whole becomes the object being inspected by the Object Inspector in the bottom left. I go to its events and select On Create. That opens the part of the code that will happen when the form is created. I need to give 2 instructions to our media player named Media Player 1. First instruction, hey media player, load my icy sound effect. MediaPlayer1 dot filename := apostrophe sounds, because that's the subfolder I created, \iceblast, because that's the name of my file, and then the file extension, in this case WAV, apostrophe : The second instruction to the media player is really easy. It's the instruction to play. MediaPlayer1 dot play : Let's see if it worked.
Two.
In preparation for tip 2, I've added 4 more pictures to our images folder: a snowflake, a penguin, a blue button, and a gray button. Tip 2 is to never insert Delphi's T-buttons into your program. T-buttons are ugly, see? T-buttons are boring. Instead, get images to do the work of buttons. I'm inserting an image of a penguin, calling it penguin, but setting it to invisible. Now I'm inserting an image of a snowflake and calling it penguin button, because pressing on the snowflake will make the invisible penguin appear. To do that, I double-click on the snowflake, which creates an on-click event for it. You know the code I need to write to make the penguin appear: penguin.visible : true. Let's watch it work. Cool. I like the snowflake, but I'll show you how to create the illusion of a toggle switch using the pictures of blue and gray buttons. We'll make the 2 images the same size and place them directly on top of each other, with the blue one presently visible and the gray one presently invisible. We'll make clicking the blue button cause 3 effects: turning itself invisible, turning the penguin invisible, and turning the gray button visible. We'll make clicking the gray button have the 3 opposite effects. Now look what it does. Toggly.
3.
Tip 3 is to be efficient with the number of objects you insert. Don't use 2 when 1 will do. Consider a few examples from my railroad auction game. When Clarence is the dealer, there's a red dealer arrow over his head. When Diane is the dealer, the arrow is over her head. Initially, I considered having 4 separate images in my program, called Dealer Arrow Alice, Dealer Arrow Bob, etc., and making them visible and invisible as circumstances demanded. But there was a better way. Check out the code. Dealer pointer is a single image. I simply change its position based on who is the dealer at the time. The horizontal and vertical coordinates are set with dealerpointer.position.x and dealerpointer.position.y. So if Clarence is the dealer, make the dealer pointer be located over Clarence's head. Another example. Notice that as the AI players lay down their cards, their hand size does appear to shrink. What code made that possible? There are 4 images: Alice's hand icon, Bob's hand icon, etc. When I need Alice's hand icon to now show 3 cards, the code is Alice's hand icon.bitmap.load from file images, because that's the name of my special folder, \hand of 3 cards.png, because that's the picture of 3 cards in my image folder.
4.
Before I can explain tip 4, we need to talk about my favorite kind of object, list boxes. There are lots of list boxes in my railroad auction game, but they remain invisible. The end user never sees them, but that doesn't mean they aren't important. In my game, The Deck is a list box that at the beginning of the game contains 52 items, each one a code indicating one of the 52 standard playing cards. The part of my code called Shuffle and Deal randomly selects 5 items from the deck list box to place in a list box called Alice's Hand, and 5 for Bob's hand, and 5 for Clarence's hand, etc. What will you see if I run the program with those ordinarily invisible list boxes turned visible? That one's the deck. This one is Alice's. Here's Bob's. Here's Clarence's and Diana's. Let's go. When I press start, that procedure called shuffle and deal happens, and we see 5 random cards in each player's hand. Tip 4 is that in addition to whatever list boxes you need for your application, make one more. Call it My Debugger. When your program gets big and complicated and has lots of loops within loops and multiple paths, it's so easy to get lost. Get in the habit of leaving breadcrumbs in your code, lines of text sent to My Debugger as a record of where you are in the code. Whenever someone clicks on our blue button or our gray button, we'll dispatch a record to My Debugger. When you run the program with My Debugger visible, you get the messages in real time. Throughout the process of building your program, you'll be concentrating on different parts of it at different times. If you don't presently want a particular message sent to My Debugger, you can comment it out with 2 forward slashes. I commented out the notification about the blue button, but I'll still get the notifications about the gray button. 99% of the time, you'll run your program with the debugger invisible, but it's there whenever you need it.
5.
As promised, my 5th tip concerns my beloved Next button. Programming is like putting on a magic show. The real art is illusion. Earlier, we created the illusion of a light-up button that shines blue when it's on, but sits gray when it's off. The user thinks my program has one little green Next button, but in fact it has 14. They all just look the same and appear in the same spot. Every time an AI needs to toss a card on the table, a green arrow appears that, when clicked, launches the tossing sequence. I name that arrow Proceed to Toss Preamble. Every time all 5 players have tossed and it's time to see who won the trick, a green arrow appears that, when clicked, causes that effect. I name that arrow Proceed to Winner of Trick. Tip 5 is that if you choose to go this route, create a procedure called Make All Arrows Invisible that does exactly that. What is a procedure, you ask? A procedure is a standalone set of instructions. Phonics 100 currently has 4 procedures. Form Create is the set of instructions followed as soon as our program window opens. That's where we put the sound effect. Penguin Button Click is a set of instructions followed whenever the user clicks the snowflake. Same idea for Blue Button Click and Gray Button Click. You'll notice that these 4 procedures have something in common. They all say Sender T Object. That tells us that they are prompted by the user interacting with an object visible in design mode. In fact, we created all of them from design mode. But we can also write procedures that aren't like that don't say Sender T Object. To do that, just type the name of the procedure you want to write into the list of procedures at the top of your code, and press Ctrl-Shift-C all at once. Phonics 100 doesn't have any arrows in it at present, but let's pretend it has 4, named Arrow 1, Arrow 2, Arrow 3, and Arrow 4. Write the code to turn them all invisible. Imagine we want pressing the blue button to make Arrow 3 visible. Put 2 new sets of instructions in the blue button click procedure. First, call the procedure Make All Arrows Invisible. That will ensure that none of the other arrows remain on screen and in the way. Then make Arrow 3 visible. Let's go ahead and add the arrows to the program now. I find a pretty picture of an ice arrow and save it to my Images folder. I add 4 identical versions of the ice arrow to the program and put them on top of each other. I set their positions to x equals 656 and y equals 264, so I know they'll all be perfectly overlapped. Then I name them arrow 1, arrow 2, arrow 3, and arrow 4, and make them all invisible. When I run the program and press the blue button, I'm confident that the arrow that appears is arrow 3, not any of the others. To review, my top 5 tips are: keep all the content you'll need in the debug folder, don't bother with ugly T buttons, don't use 4 dealer pointers when one will do, create a normally invisible list box to help you debug, and if you plan on superimposing identical buttons, create a procedure to make them all disappear. Have fun gramming!